In this video, we're going to continue on with section 10.4 and we're going to talk about quadratic functions and their graphs. But this second problem talks about parabolas or quadratic functions that are of this interesting form, where we have a times a quantity x minus h squared and then plus k. And this is called vertex form. Okay, so you might want to remember that. This is called vertex form versus standard form, which is the ax squared plus bx plus c. So for this form, you have the vertex point hk, which you can pull directly from your equation, where this is your h value and this is your k value. Now it's important to remember, and I'm going to bring it up again, that this is x minus h. So if it really said something like x plus 3, you would need to rewrite it as x minus negative 3, or at least remember that in order to get your h and your k value. Similarly, your axis of symmetry would be the line x equals h, because it goes through that x coordinate of your vertex. So if you're going to graph functions that are in this form, the first thing you need to do is decide, does it go up or does it go down? That's always a good thing to look at with your parabola. And remember, your a value, I'm going to put that here, is look at your a value. Remember, if your a is positive, it opens up. If a is negative, it opens down. Then you're going to find your vertex, h and k. You're going to look for any x-intercepts by setting it equal to 0 and solving. And then you're going to look for any y-intercepts by plugging in 0 for your x value. And then finally, we connect all the points using a smooth curve, and that's our parabola. So let's give it a roll and see what happens here. Okay, so here is our function of this form. F of x, I'm going to write this again, equals a times x minus h squared plus k. So the first things first, does it open up or does it open down? Well, this one opens down because our a value is negative 1. So this is going to open down. So keep that in mind. And then I want to look at for my hk, my vertex, right? So remember I said if this is plus, like this one is, we actually need to think of this as negative x minus negative 1 squared and then plus 4. So my h is negative 1 and my k is positive, I wrote k, it's positive 4. Okay? You don't even have to write positive 4, you could just write 4. There we go. So my vertex is negative 1, 4, and I could put that right in here on my graph. That's going to be my vertex, and in this case, since it's opening down, that's going to be my highest point. My axis of symmetry is always just x equals whatever my h value is, negative 1 here. So now we're going to look for our x-intercepts, which is where we're going to set our problem equal to 0. So I'm going to say this is where we have f of x equals 0. So I'm going to do it over here because I got a little more room. 0 equals negative x plus 1 squared plus 4. Now I want to solve this, so in order to solve this I need to get this quantity by itself so I can take the square root of it. So now I have negative 4 equals negative x plus 1 squared. Divide by negative 1. And I get 4 equals x plus 1 squared. Now we're going to take that plus or minus square root of both sides. So I get plus or minus 2 equals x plus 1. So what I have is x plus 1 equals 2 and x plus 1 equals negative 2. When I solve, I get x equals 1 and x equals negative 3. Remember, these are our x-intercepts, so I write this as positive 1 comma 0 and negative 3 comma 0. I can put that in here, positive 1 and negative 1 to negative 3. The y-intercept is what I get if I plug in 0 for x. So f of 0 equals, I'm going to switch to a different color here, negative 0 plus 1 squared, and then plus 4. 0 plus 1 is 1. So negative 1 squared plus 4. And this becomes 1 squared is 1, so this becomes negative 1 plus 4, which is 3. So I'm going to put that on my graph here at 1, 2, 3. Now remember that our parabola has to be a smooth curve. So I'm going to connect these points. This is my top point. So I'm going to connect these points as I go down. And knowing that it has to be symmetrical, I know that this point here has to be in there as well. So that's going to help me make my smooth curve as I go down. It's not perfect, but you get the idea. And that's what I would be looking for if I were grading this on a test. Okay? So let's take a look at the next one. Sometimes you will be given a function like this, and you will need to rewrite it into this x minus h, a times x minus h squared plus k form. It's not too challenging to do, you just have to remember how to complete the square. That's what we're doing. So here's how I look at this. Okay, I rewrite this so that it looks like this, and I just give myself a little space here. Normally, if this were, we were solving and we were completing the square, we would move the 10 to the other side. But since this is a function, we're just rewriting it. I just moved it out and gave myself a little space. So remember, to complete the square, I take half of this b value and I square it. So negative 6 over 2, which is negative 3. Negative 3 squared is 9, right? So I'm going to add 9 here. But notice, since I'm on the same side of my equation, I'm also going to subtract 9, because I have to have it so that I'm not actually changing the value of my equation. So I'm adding 9 and subtracting 9 from the same side. Typically, we add 9 to both sides of our equation, right? So I would add 9 over here, but in order to move that to the other side, I would then have to subtract 9. So this is why I'm doing it just on the same side of the equation. So then what I have is f of x equals this piece here. I just completed the square on it, so that I can rewrite as x minus 3 squared, and then I have a plus 1 out here in the end. All right, not terrible, it's fine. My vertex hk, well, this is x minus h, so my h is 3. And then plus k, so my k is 1, so my 3, 1 is my vertex. I forgot to say, does it open up or does it open down? Hopefully you've seen that, in fact, it is going to open up, since my a value is 1, and that's positive. Okay, so my vertex, that's the lowest point. My axis of symmetry would go right down through that, remember? Now, x-intercepts, if they exist, if my parabola opens up like this, what are we going to know? This is my lowest point. It's never going to actually cross my x-axis. If I had a negative a value and it opened down, then yes, sure, it's going to cross the x-axis. But this one is not actually going to cross the x-axis. So these do not exist. The other way you could figure that out is if you were to set this equal to 0 and solve it, right? If I were to say, well, 0 equals x minus 3 squared plus 1, when I go to solve this, what I find out is negative 1 equals x minus 3 squared. Take that plus or minus square root of both sides, and what do I get? I get plus or minus I here equals x minus 3. I can solve that. I can still solve that. And what I get is x equals 3 plus or minus I. But this means it's imaginary, and therefore I cannot put it on the graph. Okay, so the last thing I want to do is I want to figure out what the y-intercept is, and that's means I plug in 0. So if I go back to my equation here, that looks like 0 minus 3 squared plus 1. This becomes negative 3. squared is 9, so this is 9 plus 1, which is 10. So I have the point 0, 10. So I'm going to put that up here. And remember my parabola, now I need to be able to make a curve, and I need this to be that bottom point, so it has to be symmetrical. So when I'm over 3 this way, it's up at 10, so I go over 1, 2, 3 this way, put it up here at 10. This is what's going to make my parabola symmetrical. Now it doesn't have to be perfect. I really only have to have these 3 points. There are some other ones in there I'm sure I could figure out, and if need be, you could make a few of these other points using a table of values. You could figure them out, but ultimately this is what I've got. Oh, I forgot to write the equation of my axis of symmetry. This would be x equals 3, which is always my h value, and I could actually even graph it on here, and it looks like this. Okay, so that's how we work with quadratic functions that are in vertex form, or how we put them into vertex form if they're not already. That's all for this one. We'll see you in the next video.